I'm very thankful for the invitation. It's a pleasure to be here, and I apologize because my scientific talk will be embedded into another talk, which is a bit philosophical. So to define the role of experiments or experimental surgery is not easy. So I have to start with some introduction, which is introduction to best practice. Thereafter, to show you the difference, the subtle but important differences between experimental surgery and surgical research. Thereafter, I try to introduce the building blocks, the experiments, the community services, education, and finally, I try to give an example how to design a real par excellence surgical research protocol. So to start at the beginning, why do we need best practice? And the answer is very simple, to learn, because in a time of drastic change, according to this motto, the learners who will inherit the future. And I think it's a very good start to describe the importance of best practices. Why do we need best practice, or what is the goal of best practice? The answer can be something which relates to personal profits for the surgeons, for the patients, for the researcher. But more importantly, there are community profits. And the answer is maybe to keep surgery, we are talking about surgery and best practice in surgery, so to keep surgery at the cutting edge of medical sciences. Fortunately enough, we have numbers. These are describing efficiency, productivity, and scientific quality quite easily. For instance, this number, which is collected from these databases, this is from 1996 to 2009, and this is until today. This very nicely and clearly shows us the first three members of the group of excellence: United States, United Kingdom, and Germany. So these are the countries which are producing the best of the best in surgery, with the Hirsch index, which is the number which you are seeing here. And this database is also able to make comparisons. We can compare countries with high Hirsch index in surgery with countries with lower or lowest ranking indices. And it's a visual description of the differences. And here you will find the most significant one. And this is multidisciplinarity. Countries with low age index are communicating with biochemistry only. Countries with very high and very productive, very excellent scientific output are multidisciplinary. The surgery, which is here and here, is attached to different subspecialties, and there's a very strong link to a general point here, which is described as multidisciplinarity, and then comes biochemistry, applied mathematics, and so on, and so on, and so on. So the co-citation network shows us the most important point to consider in case of excellency in sciences, and specifically in surgery. So the first message is, the first conclusion, the best practice is to have as many cooperative partners as possible. If you look the word multidisciplinary in the Wikipedia, then you will find this definition. It's a non-integrative approach in which teams are working in different disciplines to collaborate. So the next step is, what is the difference, or what are the links between experimental surgery and surgical research? And there are, again, very important and, I would say, very interesting definitions. So the experiment, as we all know, it's a type of research study which will test the idea that one variable will cause an effect on another one. So this is a very simple approach to define experiment. Surgical research, however, is a bit different. It starts with a disease or a clinical problem of interest to the surgeon, and it has benefit to the patient, and this is the ultimate goal. This is the main message of surgical research. It has to be useful for the patients at the bedside. And this graph shows you the difference between basic scientist and the clinical scientist or clinician. These are the experiments which can be performed in vitro or in vivo or using human subjects. Surgical researcher is something in between the clinician and between the basic scientist, dealing with both parts of sciences equally. So the question is he or she, or is it a good surgical research? And the answer is, well, it's a good experiment, but as a research, maybe not excellent. Firstly, it is done alone, so not in a team, but of course, there are some other messages of the screen as well. So the classical definition of a surgical researcher is that the researcher is an investigator, and he's a bridge tender, channeling knowledge from the biological science part of the channel to the patient bedside and back again. It was said by Professor Francis Moore. He was the youngest surgical professor ever of the Harvard Medical School. So conclusion number 2, or summary. Surgical research is equal with an action where the results should directly or indirectly will influence the action of medical surgery. The methodological demands, however, for this internationally competitive surgical research has increased. Surgical research should cover a highly variable, a very broad spectrum of multidisciplinary methods to support the needs of clinical surgery. So the clinicians alone are not able to follow the progress in basic research, thus cannot contribute significantly to translational research. So what are the building blocks? This is part number 3. So what are the ideal building blocks of a surgical research or surgical research institute? There are 3 main parts of these actions. The first is the basement, which is experimental surgery. The second one is surgical techniques and technologies. And finally, education and community services. Let's see them one by one. So experimental surgery, for instance, it's a multidisciplinary basic medical science or sciences dealing with systems biology, cell biology, in vitro, in vivo models, immunology, inflammation, sepsis. We can name a few: hemodynamics, respiration, microcirculation, replacement of animal experiments, so many other topics can be listed here. The second floor, community services. Design of novel methods, novel invasive or non-invasive techniques and technologies, new surgical tools, suture materials, quality control, biocompatibility tests, scoring systems, systematic reviews, evidence-based guidelines, so many. These are all related to community as a whole. And finally, education. This is the second floor. Again, multidisciplinary and practical training, graduate courses on surgical techniques, traditional techniques or traditional surgical methods, and new, for instance, like minimal invasive surgical methods, medical or non-medical skills training, skills courses, simulation activities. Here we can name postgraduate training for surgical residents of different fields, continuing medical education, laboratory animal science studies or courses, surgical science schools like PhD schools, and so on. So these are the building blocks of surgical research as a whole. So to summarize the third part, what is the conclusion? So the characteristics of surgical research is a nice balance between the practice and basic sciences built on a foundation of surgical education and community services. So I think it's a visual depiction of surgical research as a whole. So now let's go to our aim, to our goal. So how to design a typical surgical research protocol. So I've chosen this molecule, which is our hobby during the last few years. This is methane. But let's start with the clinical problem. So what is the problem at the bedside? The problem at the bedside, for instance, in this patient is that he's suffering a heart attack. Thereafter, he's operated. The heart will be operated, and the so-called extracorporeal circulation, a heart-lung machine, is introduced into his or her body. This extracorporeal circulation will induce an inflammatory reaction the blood contact with the foreign surface will activate cellular and humoral cascade systems. And if it's uncontrolled or persistent, then endothelial damage is the secondary cause with leukocyte endothelial cell interaction. So it's a typical antigen-independent inflammatory reaction leading to distant organ damages, including the damages of the kidneys. So the final result of this extracorporeal circulation-induced problem is renal dysfunction. It's very, very common. The majority of the patients after a heart-lung machine governed operation will suffer from different degrees of renal dysfunction. So the next step is how to improve this condition, how to influence, how to change this reaction. And this is one of the possibilities, of course. So the hypothesis was that if we are administering exogenous methane into the circuit, then we can reduce the ECC-induced renal dysfunction. So this is a very simple, seemingly simple question and a seemingly simple protocol which is used to solve this question. Let's analyze a bit. So why methane? Methane is a biogas. It's non-toxic, one of the least reactive organic substances. It's non-toxic, nevertheless, if the concentration is increasing up to a certain level in a closed space, then hypoxia is the secondary cause when the concentration of oxygen is reduced below 16%. It's combustible and forms explosive mixtures with air if the concentration is increased above 5%. The principal sources in human or in mammals is the process of digestion, so it's an endogenous substance. Nevertheless, the role of this gas in humans is absolutely unknown or not known. Nevertheless, there is an anecdotal evidence from 1968. It was a Russian scientist who described the first time that the rats who are bled to shock, so hemorrhage shock was induced in these animals, and were treated with a methane air mixture, then the survival time was increased. Later on, we also examined this possibility, so we also studied the effect of methane on inflammatory reactions, and we also found several comparable results. In summary, methane as a gas has anti-inflammatory properties in certain situations. Then comes the protocol. So this is the protocol which is needed to solve this question. It's not as simple as the hypothesis. So the large animal model which is used to solve this question is comprising of these different setups. For instance, to measure methane, we need a photoacoustic laser spectrophotometry-based methane detector. We have to anesthetize, we have to ventilate these animals. These are pigs. In vivo histology is performed to look for the histology of different organs. The blood flow, which is the target of the methane therapy, should be monitored, so it's a ultrasound flow-based detection possibility on the kidneys. Blood gases should be checked. The intestinal microperfusion should be checked. This is the machine which is used to, it's very similar or maybe identical to the human situation. Macrohemodynamics are recorded, and we are taking samples from different organs to check the function of mitochondria. The microcirculation not only examined with laser Doppler flowmetry, but with a special intravital video microscopy as well. So it shows you the multidisciplinary and the very complexity of this setup, I think, quite vividly. So this is the team. So the next step is to recruit the members who are working with this protocol. And of course, again, it's not the whole story, the whole team members are shown here. Surgeon from the Department of Cardiac Surgery, so Dr. Bari, he's the one who is linking us to the clinical practice, surgical researcher, secondary student, school student, physicist, PhD student, physicist, cardiac surgery resident, biologist, secondary school student, biologist. So as you see, it's a quite large view on multidisciplinarity. Some photos are taken to show you how it is running in real-life conditions. And some of the results. This panel shows you the artery flow in the renal perfusion field, and this one is the diuresis, so the urinary output. If we administer methane, you can see very large differences between the non-treated and the treated group. These are the average of 6 animals, so if we administer methane, then our diuresis is increasing significantly, and the arterial blood flow is increasing as well. So there is a clear difference between these two groups. So the answer is methane is bioactive. The experimental protocol, which we designed, targets important surgical pathophysiologic issues, employs multidisciplinary methods, has educational aspects, and hopefully will provide benefits to the patients as well. So I think it is a typical surgical research protocol. And of course, as you see here, there are our secondary school members. So more simple protocols are also available, and this one is a protocol for primary school surgical researchers. Finally, these pictures were taken yesterday only, so I had no time to put the names on it, but this is the crew with our students on this cartoon. So thank you very much. This closes this experimental surgery, presentation. Thank you very much.